That sounds great. Hello, Carrie.
Oh, hello?
There you are. Hello, hello.
Hey, how are you? There we go.
Good.
Doing just fine.
Nice.
Okay.
All right.
So then we can start going through the material then if you want to.
Very well.
Okay. So I think we all need to support one each other tonight. I'm not feeling that confident tonight, but I'll do my best. So the part 2 says match pair T procedure. A manager at a factory feels that the amount of time that his workers spend doing their part in the assembly line is too long. He measures the amount of time in minutes 9 of his workers take to complete 100 products. After implementing the new procedures, he can measure the amount of time in minutes the same 9 workers take to complete 100 products and obtains the following data. He wants to know if the mean assembly time is different and use the level of significance of alpha equal 0.05.
Okay.
So then we need at first to design the study.
So the question is your production time any faster after you implement the new procedure?
That's what we need to find out. And it says state the null and alternative hypotheses. The null will be equal to 0 and alternative not equal to 0.
Right.
Number 4 was to collect the data.
Yep. So this one, they laid it out pretty good in the paragraph that he had 9 workers and he timed them in minutes to see how long it took him to do 100 to produce 100 units. Then they implemented the new plan and timed the same 9 employees to see if there was a decreased time in their performance.
Correct.
Right.
And it says describe the data collection procedures.
And that's what I just stated.
Mm-hmm. Yes.
Yeah. Yeah.
Then it says for number 5, describe the data. And it says in a short paragraph, use some statistics to describe the data. After the paragraph, insert an appropriate and well-labeled graph to illustrate the data.
So on this one, my graph, when I finished it, was, I mean, I did one and it didn't look bad. But do you guys remember, is there a special place for us to make the histograms? Because just using Excel, it's a lot uglier than the template from school.
Yeah, I just keep using the thing that they gave us that has it on it.
Okay, I didn't go back and open that up today. I just stayed right in the Excel spreadsheet and plotted it. It looked real similar. It just, there was a couple of other variances that I didn't like.
Yes. The one I'm using is the one which is called the quantitative descriptive statistics, which has for the histogram, for the QQ plot, and some others.
Yeah.
I'm just going to go ahead and open that up and throw it in there just to see what it looks like.
Okay.
While we're chatting, go ahead and keep going, Carrie.
Okay. So then it says for number 6, making the inferences. So for letter A, what type of hypothesis test is appropriate? Just wrote down the two-tailed to verify if it's more or less in time.
Yeah.
Then for letter B, it says, what are the requirements for this test?
It seems like all of the tests are going to have the same type of requirements, that it has to be from a random sample, and that you need to make sure that it's what sort of normal distribution. And as long as you have those qualified, then you can go ahead and move forward, correct?
Yes.
That's what it seems like, yep.
Okay.
So then it says for letter C, continue with the test regardless of what you found in part C. Compute the test statistic. So for the test statistic, I found it for negative and positive 1.22.
That's what I got also.
This was just in the formula T equal to the sample mean minus mu divided by sigma not known divided by square root of n. So then it was asking to state the degrees of freedom.
So did you go ahead and compute that out, Kevin, by hand, or did you just use the template?
For this one, I did it by hand.
Because I just trusted the template and plugged it in there.
But I use the template.
Yeah, then I
also.
just reconfirm it again with the template. With the formula, it was just T equal to negative 1.056, which is the sample mean, minus 0, which is the null hypothesis equal to 0, then divided by the standard deviation, 2.596,
right?
Divided by the square root of 9.
Yep. Oh, it makes sense. I just didn't go through and calculate it out.
Okay. But no, it's the same with the applet as well. But for this stuff, I just did it manually. Then I used the applet just to confirm that it was right.
Yeah.
Okay.
Okay. So for degrees of freedom, using the formula, which is this sample minus 1, that's just 8.
8.
That's what I had as well.
Then for letter, okay. Then for letter E, it says compute the p-value to the alpha level, sketch the t-distribution using the t-distribution applet. So with this one, I remain with both extremes shaded and having an area of 0.2572.
2572. Yep.
Yep, that's what I got also.
Yes, our p-value going with letter F. Since the p-value is greater than 0.05, so we fail to reject the null.
How about it?
Yes, we'll fail to reject it because it's
You better go small.
larger than the 0.05.
Yes, Mom. Plug that back in if she says no, okay? Sorry about that.
It's fine. So we were discussing that we fail to reject the null since the p-value is greater than the alpha value.
Yep.
So the test, present your conclusions in the form of an English statement.
Yeah. And I tried to follow their instructions and have it be, we have sufficient evidence to that the time it takes a worker to make 100 products is different after new implementation.
Yes. As I just wrote down, we have insufficient evidence to say that time taken to do the 100 products, it's not different after implementing the new procedure.
Mm-hmm.
Just different wording, but same point.
Yep.
Right.
Okay. Now for letter H, it says rather than testing a hypothesis now, so you just wanted to estimate the mean difference between wait times at the 95% level, what would you do? Be sure to calculate the margin of error, do it and paste your results below.
So this is one of them where I it was so simple, it was stupid. I scratched my head over and over and over trying to figure out why I couldn't get it to be centered, but I just trusted the applet at this point and went, you would show the confidence interval because you know it's a 95%. It's got the degrees of freedom in there, and whatever it gave me for the confidence interval is what the range is, and that's what I put in there.
Yes, but this one I used the spreadsheet, which is called the quantitative inference procedures, the one we used for last lesson. Just entering the mean, standard deviation, adjusting to not equal to, the confidence level, and I came up with a confidence interval.
That's what I did also, yeah.
So in that,
Use that.
you guys end up with negative 3.051 and 0.940?
Yes.
Okay. Yep.
Alrighty then.
So then it says take action. In a short paragraph, describe the action you feel should be taken based on the statistical results above.
Well,
I was just thinking they need to think for something different if they would like to reduce the time of making those products.
alternative idea.
Yeah.
Because this is not working. And just to point this out, whenever I was calculating let me go back to that one, the one which was asking us to calculate the test statistic.
Right.
Just to come up with the sample mean and all of that, I just did the process of the difference, taking the two columns for times, then just having the post minus the pre statistic, and then just making the sample mean from that range.
Right.
Yeah.
Yes, as I was saying, with the procedures, I have no questions, but really understanding the concepts, it's just coming with time, I think.
Concept of what? I said I'm going to go back and review last week's readings, just to help, I think.
Yes, it's because it's just changing a little bit, just by having two different columns with statistics instead of just one, and finding a difference in between those to find a margin.
Yeah.
Okay. So then, any questions, or would you like to move on to the test?
Might as well move on to the quiz, I think.
Okay.
I agree.
I just pulled that one up. Okay, so this one is true, this one is true. Okay, so there are two files that we will be using.
All right.
Let's bring those up.
Students' probability, the t-distribution one, correct?
Yes.
All right. And I'm going to, I don't need factory times anymore, correct?
Yeah, it doesn't look like it.
I'm not going to need man. And I'm not going to need my other one. So let's see what we got going on. Okay. Open that one. And open that one. Do we have a test this week?
I think it's next week.
Okay, I've got a test in my other class this week, and I was hoping to not have two at the same week.
Yeah.
All right.
Those are funny when those are proctors.
All right. So I've got both of those open now and ready to use.
Me
And I'm
too.
assuming we're going to be using the interference like we did before, correct?
Mm-hmm. Yes.
All right.
Appear data. D. So then it says for the information, let D equal the X after minus the X before. The null hypothesis will be equal to 0. And the alternative not equal to 0. Says, and the population standard deviation is not known. Jordan includes a sample size n equal 9 and computes D equal to 0.2. And the other it's 3.30. Standard deviation difference 3.3. Then it's asking for question 3, what is the value of the test statistic?
So this is going to be T equals, what's that calculation here? Real quick? T equals D bar minus 0, correct?
Yes.
D bar minus 0 divided by this deviation
3.3.
3 minus S3 divided by the third of n. So that ends up being what, buddy?
Coming up with T equal 2. Is that what you're getting?
Two point 3.3 divided by 2 is what I got.
Me too. Yes. It's by having 2.2 minus 0 divided by 3.3 divided by the square root of 9. Just coming up as 2.
Yep, that's what I got. Perfect.
Okay.
So 2 is our final answer.
2.
Yes, that's what I'm getting using this formula and the information given. Then it says question 4, the probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. Use this probability to determine the p-value for Jordan's hypothesis test around 2-3 decimal places. So the p-value using that applet. And
what is the probability greater than? So use that.
Have 8 degrees of freedom, right? We got to put that in?
yes. Yes, 8 degrees of freedom.
No, go talk to Mama. My daddy's taking class, okay? All right. 0.04.
Great.
I am getting as p-value 0.081.
I got. Hold on, my numbers. So again, 0.4844. We're doing greater than, right? So we would shade the right side.
Yes, it's just the right side. Yes, then I am getting it just shading the right side. with 8 degrees of freedom, 0.040. I always having both sides shaded.
So when I put the probability at 0.0403 with 8 degrees of freedom, I end up with a t-score of 1.999.
Well, but using the t-distribution applet,
Right?
and we have the t-value for 2, I am just typing it as at the bottom section, and then just hitting enter, having above the 8 degrees of freedom, it's bringing up 0.040. Just having the right side shaded, because as Kira said, it's looking for greater than.
Right, but
Okay.
so isn't your area, isn't that where you put your 0.043?
Or do you put it with the t-score because that's the test statistic?
Mm-hmm. Yes,
So you put it on the
wouldn't.
bottom, right?
Yes, because it says the probability of obtaining tested is greater than Jordan's test statistic S. Use this probability to determine the p-value. Yes, because it's given us in here, just trying to understand the word, and it says the probability, it's as we are getting, just having the greater side shaded, and it's 0.0403. But this is asking for the p-value. And if not mistaken, the p-value is having both extremes shaded. Or am I wrong?
I always thought the p-value was just the area after you put in and you shade whatever you needed, then whatever is in the area was the.
Yes, that's the p-value. But if we had just shaded the right extreme, it's given us exactly the same what the question is given us, 0.0403.
Right. So the probability is your test statistic, is what you're telling me.
By entering the test statistic on there, it's 2, and I am coming with 0.081.
My brain's fried tonight. So let's just real quick. The 0.0403 goes in the t-score.
I am not touching that information because the way that I remember calculating the p-value is just by entering the t or the c-score at the bottom part of the applet.
That right, I understand that. That's what I'm asking. So, enter. Where are you entering that information that's given?
Because if I just entered on the area the information given of 0.0.
Right. I understand that, Kevin. Where are you entering the 0.04? Where are you putting that information in there?
No, I am not entering that information. I'm just entering the t value for 2.
Right, I understand that. We're saying the same thing. They're giving you information in the question of 0.043. That's what they gave you for the information, right?
Correct.
In the question, where are you inputting that in the applet?
If we need to enter that one, we need to enter that one in the ARIA. In the ARIA section.
0.403. That information
is for the 2 in the t-score, the area is at 0.0403.
I'm sorry, what was that, Kerry?
Well, when you enter the 2 for the t-score that we got from the last question, then the area, it pops up as a 0.0403. So that's
okay. So you put the 2 in the t-score. Is that correct?
Right.
Yes.
Okay. Okay, so I see that so far. Now I guess where my brain is frazzled is what exactly are we trying to answer here now?
That's where I'm stuck too.
Because it is asking for the p-value. It says use this probability to determine the p-value for Jordan's hypothesis test. So this is, as you were saying, Sean, this is asking us to use that probability, which is 0.0403, to determine the p-value for Jordan's hypothesis test.
Okay.
Correct? It's just written that correctly.
That's what it says.
So then we need to use the 0.0403. So we enter that in the area, failed, and that's coming up with t equal to negative or positive 2.444.
So if I put 0.0403 in the area and hit enter and shade to the right, so p-value is only if they're both shaded, correct?
Yes.
Right.
So then you would shade both and you would end up with 0.805.
Right. I think that's what it is.
Mm-hmm. Yes, that's what I am thinking, that it's the answer, 0.0881 if we round it.
81, yeah, round it up. Right.
So 0.081.
Correct.
Yeah, that's what I have.
All right.
Okay. So that says the next one. Use the data for file chapter 12 data, and the name, it says to answer the next 6 questions. Perform a pair sample t-test in SPSS. Be sure that a test does group 1 minus group 2. Use the null hypothesis and alternative hypothesis 0 not equal to 0, and level of significance 0.10. So the first question, it says, what is a test statistic? Let's go ahead and do so. It's just this one.
So this is a 90% confidence interval on this one, correct?
Yes.
Right, yeah,
Make sure my brain is correct here and following suit. All right, so this is a 90.90. It's not equal to.
well, I got 0.407.
Let me just go into some manually. 574, 6.9. Seven. Three and negative 4.
So in this question, is this column 2 minus column 1?
Yes, we need to find the mean and the standard deviation by subtracting both of them.
All right. Okay, so I had a mean of -31. That's not what you want yet. Test statistic is the t-score. I have negative 0.407.
Mine was positive.
Let me do some manualing here. The main is negative 31.25 minus 0. Then we have the standard
Group 1
deviation.
minus group 2. Okay, I did group 2 minus group 1. So let me go back and change my. Sorry.
20.
Okay, so that flipped it around to where I have 407.
0.407.
Yep.
31.025. Yes, I am getting negative 0.407. Just did it manually. Yes, it's negative.
So
Is it negative or is it positive?
I got negative.
In the question, it says be sure that the test does group 1 minus group 2. So column 1 minus column 2, correct? Am I reading that correctly?
Be sure to just
That's how I read it.
Group 1 minus group 2. Yes, I just did it all the way around. Then it will be.
Yes. All of
So
the
then it
videos
will be positive. Yes.
all the videos had you do it the other way, so that's interesting.
Yes. So there's that I didn't pay attention to. So then it will be positive if it is group 1 minus group 2.
Right, I got the positive 0.407.
0.407. Then it says, what is the p-value? 0.407. Getting his p-value 0.695.
Did you use the applet?
Yes, I used the applet, the
So
distribution applet.
Okay. Why is the distribution applet different than what's than what shows up on the spreadsheet?
Yeah, on the spreadsheet, it's just the 0.68. What, it would be 689.
Yep.
Interesting.
So I think, I don't know if it's with the applet, if it's just because we round it and it's not the full number.
What's
That
the
has
degrees
anything
of
to do with
freedom? Change.
Yes, let me change the degrees of freedom. It's 19. Yes, you're right. It's 0.689. Yes. Didn't change the degrees of freedom.
So on the applet, well, yeah, there we go.
So then this one it's greater than 0.10.
Yes, it is. So we would fail to reject.
Correct.
Fail to reject.
Correct. And it says for question 8, suppose your alternative hypothesis is instead greater than 0. What is the correct decision based on this evidence?
So if we change the type of test to greater than, we still have a p-value of 0.344, which is still higher.
Yes, so then
Would be
it
the
will
second one
be,
down.
yeah, as we have insufficient evidence that the mean of the difference is greater than 0.
Yeah.
And it says for next section, use a data file, the data B1, to answer the next 8 questions. Perform a paired sample to test. Be sure that the test is group 1 minus group 2. This data. Go ahead.
Just real quick, just making sure that I'm reading this correctly. So 8, we have insufficient evidence that the mean of the differences is greater than 0.
Yes.
Right.
Okay, so then it says this data comes from nosocomial infections. The null hypothesis is 0, the alternative not equal to 0, and the level of significance 0.01. So then it says question 9, which is greater, n or degrees of freedom? That's the sample. Right, it's n.
So, and yep.
Says what is the p-value for it?
Okay, so n is 22. Degrees of freedom is 21, right? Save. There's a p-value. 0.0 3 zeros and then a 6. Was that 0.001?
That's what I show as.
Yes.
Fail to reject the null.
Says what is the decision you make? And the initial question was not equal to 0, and then it was log significance 0.01. Okay, 0.001.
So it's actually less than, so we should be able to reject
Yeah.
the hypothesis.
So it's less than 0.1. 0.01.
Yes. Alpha is greater than P. P is smaller, so you reject it.
Yes,
Right.
we reject the null. As you decide to try another alternative hypothesis, this time you use greater than 0 and you keep the same level of significance. Did the p-value increase or decrease?
It looks like it decreases.
Okay, it's greater than. Then what decision you make? Still to reject the null.
Yeah, you reject it again.
Based on your response from the previous question, what conclusion do you make?
All right, so it goes from 0.001 to 0.006, right? And so that's still less.
0.006.
Right.
Yeah.
One more 0 in there. So it's still the p-value did increase, correct?
I decreased.
It decreases.
Decrease. It adds an extra 0.
Yeah.
Mm-hmm.
Right. Exactly.
And you still reject the null.
Correct. So is it the third option going down? We have sufficient evidence that there is even difference between the two groups.
So there is a mean difference between the two groups.
Mm-hmm.
Yep.
There is a mean difference.
Then it says, as we have seen the p-values and the alternative hypothesis in general, which alternative hypothesis will give the smallest p-value?
Well, in this case, it's the greater than.
Mm-hmm. Yes.
Right.
Yes. Then it says, determine the 95% confidence interval for the mean difference between the two groups using group 1 minus group 2 and put your answer below. What is the point estimate for the 95% confidence interval?
So all we're doing is we're not changing the data, we're just changing the confidence level on this one.
Correct.
Right. And the point estimate, that's just the mean, right?
That is the point estimate. Correct.
That'd be 11.955.
Is the T the point estimate? Because that's your T stat. How do I read that?
Because the point we're taking as a reference is not the mean. 11.955.
Give me just a second. 303, 18.607. All right. That was in the reading right at the beginning. So you think it's mean? Is that what you're saying?
Yes, the point of estimate being the mean.
Mm-hmm. That's what I thought.
Okay.
So then it's given as the 11.955. Sorry, 11.955, yes.
Yeah.
11 point. Sorry. 11.9955. Right. Margin of error. Is that the standard of error from the mean, or is that your confidence interval?
I was thinking of standard error mean.
3.199.
That's what I was thinking.
Hmm.
Because the lower bound and the upper bound are your confidence interval.
Correct.
Okay. Are we ready to submit then?
Okay.
Okay. Here we go. Aha. You didn't like the margin of error. I forgot to calculate.
Let's go into seconds.
Margin of error. All right. So we missed the standard of error, the margin of error. And we also missed 15, the greater than.
What's that? Yeah. So like lower bound.
Cascading.
So I'm guessing at 15, there's not enough information. It's going to depend on the problem.
That's what I have to assume. Because, I mean, in this example, it was the greater than.
Mm-hmm.
So if not that one, then I would have to assume we don't have enough information.
Okay. I'm just going back through the reading here, trying to find.
Yeah.
Mhm.
Because the margin of error is so it was x bar minus t times s divided by the square root of n. So this has got to be, let's see here, d bar minus e times sd third n plus or minus. So if I put that in there, let's just have a quick look here. So 11.955 plus or minus 3.737. What was SD? Standard deviation. By the square root. 22. So let me try that here. 3.737.
So I am getting as a margin of error 6.652.
How did you come up with that by chance?
I was just taking the confidence interval because it's taken for granted question number 18 and 19 as the lower bound and upper bound. I just took the mean which is 11.95455 and subtracted and added from 5.303 and 18.607. Because we're taking the mean as reference, adding up the margin of error and subtracting that one.
Is that what you got?
Yeah, 6.652. Because if it is accepting the other two questions, that's right.
Right.
Mm. It's 3.19 times 2. I'll submit it and I'll see. So I just submitted the quiz.
Okay.
It's taken it right, 6.652.
So let me go back through this again then.
Take the formula, reduce it with the formula.
All right.
Simple manila.
Start the quiz all over. All right.
15.003. The square root of 22. Let me try it with the formula. 1 second. Yeah, so the formula I'm not getting it, but I just did it the other way and it was getting me the answer.
Yeah, I like that way that you did it. That was amazing.
Because if I just took the formula d bar minus 0, which is the other one, it's divided by the sigma not known by the square root of n. I'm not coming with that answer. And so I just better did it the other way.
So 2, 0.81. T is 0.47. Six 689.
I'll try another equation.
Okay, just working my way back through the quiz here to make sure I don't miss anything.
Okay.
So if 8 I guess I missed that one. So 8 is greater than. So 8 if greater than, still larger than the null, we still have insufficient evidence. Is that what you had for 8? We have insufficient evidence that the mean of the difference is greater than 0?
Yes.
Uh,
Second option, going down.
Okay. 10 is larger. All right, for 10, we had 0.001.
Correct. We rejected the null. So then we tried another hypothesis. It decreased.
Yep.
We rejected the null. We have sufficient evidence that there is a mean difference between the two groups.
Yep. There
Do
is
not
a
have
main
enough.
difference.
So 16 was 11.955. 17, 6.652. Lower bound 5.6. And up or down 18.607. And submit. Looks good. Go team. You guys are awesome.
Yes, this one was a hard one.
Yep.
But we made it.
We did. Kevin, thank you once again for recording and posting.
Absolutely. Appreciate that.
Okay, I'll post the link later after the video is uploaded. So then, see you guys on Thursday then.
All right, have a good night.
Good. Thanks, guys.
Okay, have a good night. Bye-bye.
Bye.